Okay, so now we're going to look at Boolean values and conditional statements, and you can see I've created a new class and a new public static void main string args, and I'm going to again scroll it off the screen just so you don't get distracted by it, to kind of simplify what we're looking at. All right, a Boolean value is either true or false. This is me declaring two brand new variables and then assigning one to true and one to false. So you can see here the word if, you have these parentheses, and then this can be any expression that reduces down to true or false. So if is happy is the same as true. Now equals equals, this you haven't seen before, is a question. Okay, remember, a single equal sign is an assignment. Okay, I'm assigning this variable a value of true. If you have two equals, it's a Boolean expression, which is asking a question. Is the value on the left completely identical to the value on the right? And if that is true, then we go and execute the if statement. So here I have two consecutive if statements. I'm going to print out some text if one is true, so probably is happy, and sure enough, is happy is the only thing that shows up, just as we expected. So notice that I've written the word else. There's no parentheses after it because it's automatically paired with this if, and I write system.out is not happy, frowny face, and then this else will be immediately paired with this if, and if this is false, then this will execute. So we'll see that the is not happy should not appear, and the is not excited probably should appear. And sure enough, it is happy and is not excited. Also, if you want multiple things to happen, you can have curly braces after these things, obviously. Now watch this. What if I, inside the if statement, assign is happy to be false? Now notice, if is happy is true, which it is, I'm going to execute in here. Now inside is happy is being assigned to false. Do you think that this else statement will execute because now this variable is no longer happy? It does not. There's no time when an if and an else will execute. It will always be one or the other, even if conditions inside the if statement change that seem like it would make the else apply. Now another thing that's interesting to point out is that most computer scientists would consider this redundant. The idea is that the computer is going to reduce this down to true or false anyway, so we can actually always just eliminate this. We can just say if is happy, right? This is either true or false on its own, so we don't need to compare it to anything else. So we can close all that off and just say if is happy. Notice it compiles and you'll get the same result. I'm not going to go show you. If you put an exclamation point in front of any Boolean expression, it flips it. So basically it means the word not. Okay, so you can say if not is happy. So in other words, we're asking if this is false, right? Because if I say if the opposite of false is true, that's not if is happy is false, we will flip it to true, which will then make this if statement execute. And now, this is only going to execute if it is not happy. Oh, but that actually is really counterintuitive. I should change this. So we should actually change the text in here. But you can use the exclamation point to create interesting combinations. Now let's say we want to check to see if somebody is both excited and happy at the same time. The intuitive way to do this is to put another if statement inside. So we can say if, so notice what I did here. If is happy, I come inside and start executing, and I have another if is excited. This line is inside this if statement, which means it will only execute if both of these are true, right? This has to be true just to get into here, and then this has to be true in order to get into here. So we're asking if both are true at the same time. Now notice, this else is paired with which of these ifs? Well, since we have this curly brace, it's paired with the first if, right? If I were to delete these curly braces, this else would be automatically paired with this if. So this is just counterintuitive language, right? This text implies that it's paired with the first if, but it's not paired with the first if, right? The computer is pairing it with the immediately preceding if. And this is one thing where you get into confusion if you don't use curly braces. Remember, the computer ignores white space. The compiler ignores white space. So it's not looking at how you indent everything. So in this case, since we intend for this else to be logically paired with the is happy question, we need curly braces in order to imply that. Now if I click compile, nothing actually should print out right here. And nothing does, right? I execute the main method and nothing happened. The window doesn't pop up. That's because this is true, So I come in, this is false, there's no else paired with this. I come out here, this else does not execute because we do have is happy. So your the placement of your curly braces is critical, and this is going to make for some very difficult multiple choice questions on your first test. So make sure you pay very close to that. Pay close attention to that. Okay, another way of writing this, if I have is happy and is excited, it's a little easier if we use these Boolean operators. If I say is happy and is excited. This and means both the Boolean on the left must be true and the Boolean on the right must be true in order to get inside. Delete this. The implication here is now both is happy and is excited must be true, and then I can say is both happy and excited. Now, that's going to work. Now, what is the opposite of that? In other words, if this is not true, what should I be printing up? This will print up if either is happy is false or is excited is false. So I would want to say something like is either not happy or not excited. That is the logical conclusion, and sure enough, this is either not happy or not excited. And if I come in here and I change is excited to true, sure, is both happy and excited. Similarly, what if I want to just ask at the very beginning, look, if either of these two is true, I want to execute. That is the or, and what you do is that's the vertical bar, which is you have to do shift and then it's backslash, which is right above the enter key. So if either is happy is true or is excited is true, now I want to say is either happy or excited. That's what we call this or. And then otherwise is the only way that this else would execute is if both is happy and is excited result in false. So we'll say is both not happy and not excited. That's the only way that could happen. Is either happy or excited. That's good. Now if I come back here and change this to these both be false. Oh, actually I never. There we go. So we'll put is happy is false, and notice this either will still is either happy or excited. Good. And now false. There we go. Is both not happy and not excited. Okay, so I've written two new lines here. I'm assigning is happy to become the result of this evaluation. Now, you haven't seen this before. Math is a class that has a method that returns a, we're going to call it random now. It's not truly random, but it's essentially random. A random number from 0 up to but not including 1. Okay? So if I say, hey, is this random number less than 0.5, the idea is you have roughly a 50% chance of it being less than that number, and so it's like flipping a coin. So is happy is half of the time going to be true because the random number will be less than 0.5, and half the time it will be false because the random number will be larger than 0.5. And then I've done the same thing with is excited. So now we don't know whether is happy is true or false or is excited is true or false. Okay, so now I've written a for loop that should execute 10 times. Oops, that was dumb. Should execute 10 times. I'm starting off count at 0. I'm going up to but not including 10. And I'm going to create what we call an if-else ladder. So I'm starting out with if is happy and is excited. I'm going to print out is both happy and excited. And what I'm going to say now is not, I'm going to say else if. So in other words, this will only execute if this is not true. But then I have another conditional to ask. I'm going to say else if is happy. And the idea here is this will only execute is if is excited was false. So I'm going to print out is only happy. And I'm going to do another one, else if is excited. So if it's only happy, then we're going to print out is only happy. And then I have another else. But there's two situations still, right? If is excited is true, we know that is happy must be false. Because if both is excited and is happy were true, this would have executed and we would have skipped this else. So I know that is only excited is the case. And then you can end this is-else ladder with just another else, because there's only one possible scenario at this point, right? The only way we could be here is if we are neither happy nor excited. In other words, both must be false in order to get here. So I close off my for loop. I'm going to compile. It compiles, and we should see 10 random results. It's only excited. Ah, of course. Notice that we got is only excited every single time, but that's because it's the same random value. I did another dumb thing. So what we're going to do is we're going to cut these two, and we're going to put it inside the for loop so that every single time we get new random numbers assigned in each time through the loop. So now every time we go to the loop, is happy and is excited will be assigned a new random value, and we get these random groups.